Hi and welcome to today's video. This is about word equations and pretty much is a beginner's guide to using word equations for the very first time for chemical reactions. Unlike physical changes, chemical reactions always form one or new substances. So signs that we have a chemical reaction include color change, maybe you've got a gas that's being given off, solid forming, maybe heat being given out or heat being taken in. So all of these signs are pretty much criteria to decide whether a chemical reaction is occurring. I'm going to be showing you a chemical reaction where we have a few of those signs, and it's going to be involving iron and sulfur. But many chemical reactions happen in everyday life, and some work just by mixing the right substances together. Sometimes you just need an input of energy, so what I'm going to be doing is I'm going to be using a Bunsen burner to heat my two reactants together. Now, a reactant is something that you need at the start of a chemical reaction, and a product is something that you actually make. So the word equation that chemists use to represent the reaction that I'm going to be demonstrating on video today is something like this. On the left hand side you've got reactants. So the two reactants that I've got are two elements. They are iron and sulfur, but it doesn't have to be elements all the time, it could be compounds. And we always use this arrow to show that there is a chemical change that is taking place. So the iron and sulfur is what you start off with. They're called reactants, and what we make in this particular chemical reaction is a compound. It's a product called iron sulfide. Now, don't worry about the endings of the names and the spelling of the word sulfide here. Don't have to worry about that at this stage if you are just starting your journey with word equations. Just to remember that you've got reactants on the left hand side and you've got products on the right hand side. So here is some iron. We're going to start off with this. This is one of our reactants. I've got a magnet here just to demonstrate the magnetic properties of iron. So you can see that it is magnetic. Not all metals are actually magnetic, but iron certainly exhibits that. Now this is possibly something that you've not seen before, but you may be able to see it if your teacher demonstrates it to you in class. This is sulfur. So this is an element. It only contains one type of atom, and it's a yellow powder. Sealed it because I want to make sure that everything is safe, and it doesn't actually respond in any way whatsoever to the magnet. Now, I've actually got a mix of iron and sulfur in this jar. I've pre-prepared it, and by using a physical means, it is actually quite easy to separate out the iron and sulfur. So we can be easily convinced that they are not joined together. If I kept doing this, I'd be able to separate out the iron. I'm just going to mix that up now, and I'm going to set it up so that I can actually heat these safely and hopefully make our new compound. So I've got the iron and sulfur mix inside this large test tube, and I've got some mineral wool just to stop any nasty gases from exiting while I'm heating. So gentle flame required, half open, half closed Bunsen. And let's start the process. We're looking out for some evidence of a chemical reaction. So initially the sulfur starts to melt. That's not quite the criteria that I am after, but soon enough you'll start to see some very strong evidence of a chemical reaction taking place. This is nice and safe at the moment because all of the gases are contained inside this tube. It's starting to glow red now, and that glow, you can see right in the center, is staying there when I take it out of the Keats source. So I'm just going to try this with a slightly hotter flame now. And there you can see that glow. So we're going to let that cool down, and we will check our product. So you can see that it is a dark grey dull product that's just been formed. Here's the dark grey dull product that's just been formed. At the top you've actually got some sulfur that's just formed there as well. So once that's cooled, we're going to take some out and we'll do some further testing on it. And it's now cooled down. I've got my magnet here and I'm just going to test the magnetic properties of my product, that dull solid, and as you can tell, nothing seems to be attracting the magnet. So I've made something that's got different set of properties. So this product is actually non-magnetic. It's the iron sulfide. So you may be wondering how this looks from a particle diagram point of view. So iron is pretty much a collection of one type of atom only. So there'll be thousands of those. Sulfur, interestingly, exists as molecules, but they exist as molecules with 8 sulfur atoms in a ring. So sometimes it's just easier to consider that as being on its own. But the compound would look something like this. So this is iron sulfide. So you actually find that for every 1 iron, you have 1 sulfur atom in the compound itself. At this level, you don't need to think about it any further. So that proportion of 1 to 1 is actually something that's very, very important in a compound. You've got to make sure that you understand that in a compound, they are fixed proportions. So that's a very, very important learning step for you, Jay. Thanks very much for watching. Hope it's really helped.